we have b plus 3. And on the other side of the equal sign, what's changed is now we have b plus a. So now the b is getting added with 3 on one side and with a on the other side. Now there's 3 values being rearranged. And so that makes it now the associative property. Property of addition. Next, number 3, I see on the left side we have a times b. We also have a times b on the right side, but that's all getting added to by 0. So that's the identity property of addition, because when we add 0 to anything, it stays the same. What's the difference between the left side and the right side of number 4? I see on the left side we have this negative 2 plus 2. And on the right side we have 0. Well, 2 plus negative 2 does equal 0. And that's because you added inverses together. So that's the inverse property of addition. What's going on here? So I noticed that we have c times a plus b, and here we have a plus b, still in parentheses, times c. So what changed from the left side to the right side? The order of the multiplication with the parentheses, a plus b, switched with the c. So really it's kind of like, I'm going to use different letters, it's kind of like we had x times y equals y times x. If you think of what's in the parentheses as y, we just change the order of the multiplication. And you can do that with multiplication. So that's because it's 2 things switching order. It's the commutative property of multiplication. What happened going from the left side to the right side in number 6? Well, they took b times c, and they also took b times a to get bc plus ba. That's the distributive property. Boom. Let's keep rolling. So here it says determine which of the following sets of numbers each value belongs to. Note there may be more than one answer for each problem or each value. So here's our options. We have real numbers. By the way, at this point in your math career, pretty much everything you've seen is a real number. Rational numbers, those are numbers that can be written as fractions. Irrational numbers, those are numbers that really can't be and have some crazy, never-ending decimal or decimal that doesn't have a pattern. There's natural numbers. That's the way my kid who's not 4 years old yet can count or does count. Integers, positive natural numbers, and then also the negative natural numbers, and including 0. And whole numbers are the natural numbers with 0. So when my kid counts, that's a very natural way of counting. She counts 1 first. 1, 2, 3, 4. That's what our natural numbers are, as your notes should say. Whole numbers include 0. Integers include the opposites of those numbers, or the negatives. And so then these again are fractions, and these can't be written as a fraction. So this is a fraction, so it is definitely rational. And again, every number that you've ever seen in your life is a real number so far. At some point we'll talk about imaginary numbers. Negative 18. My kid does not count or think about negative 18. Negative 18 is not a natural number. It's not a whole number, but it is an integer. And you can equivalently write it as a fraction, because you can say negative 18 divided by 1. So it's rational, and it's also a real number. The square root of 19. That's like 4 point something something something, and that decimal after, or the value after the decimal is doesn't really have a pattern, so this is irrational. But it is still a real number. It's some value. It's just hard to get a grips of the decimal value of it. 1/3 is a fraction, so that's rational, and it's also a real number. 4. My kid does count to 4 when she's counting, so it's a natural number. It's also a whole number. It's also an integer. It's also rational because you can write it as 4/1 and it's equivalent, and it's also real. Negative 2.3, that can be written as negative 23 divided by 10. That's it. That's equivalent to negative 2.3. So it is rational and it's real. Feel free on any of these things to Google practice with these types of properties, and I'm sure you can Google practice with the answers so you can check them. These kind of things just take practice. Write the following expressions using exponents. So here the base is x, and there's 3 of them getting multiplied together, so it's x to the 3rd, times, that's right there, times, which we don't actually have to write that dot down, we can leave the dot off, y to the 2nd power, because there's 2 y's getting multiplied together. Here, what's getting multiplied together repeatedly? 3. This is 3 to the 4th power. This negative comes down. Just like that. Or you could write it like this. But either way, when you punch either of these into your calculator, the answer is negative, I believe, 81. But it should be negative, because this is a negative value. Here, we're repeatedly multiplying negative 3x together. This whole thing, this whole clump that I just wrote in parentheses, is getting multiplied by itself 3 times. If you don't use the parentheses here, this is wrong, don't do this. If you just do this, you are just saying that x is getting multiplied by itself 3 times. And this is not equivalent to what's up top, what's written for the initial problem and what I wrote right there. Plus, we've got x to the 2nd power. All right, let's use our order of operations. I like to write PEMDAS like this. I don't think it's as good the other way. Because when we do multiplication or division, we have to do it from left to right. And when we do addition or subtraction, we have to do that from left to right in the problem, whichever operation comes first in the problem that you're doing. Let's start with parentheses. That gives us 7. This is multiplication. So we have 7 times, in other parentheses, we have 4 squared. So we've done the parentheses. Now we move down to exponents, because 4 squared is 16. And we're multiplying that by 7. You can use a calculator, or I think of that as 70 plus 42. 7 times 10 plus 7 times 6. So that's 112, I guess. Check out the calculator. Here we have negative 2 divided by, working in the parentheses, 2 squared. So that's negative 2 divided by 2 squared is 4. So we get negative 1/2. Alrighty. In parentheses, we have to do parentheses first. So we have negative 2 to the 5th power plus negative 2 to the 5th power. So here I'm going to write this out. I'm going to expand this. You don't have to do it, but it's going to help you get the right answer. My base here is actually just 2. Oops. Ooh. I'm taking 2 times itself 5 times, but then I drop the negative down. Whereas here, I'm taking negative 2 times negative 2 5 times. Ooh. Negative times a negative times, when you have an odd number of negatives getting multiplied together, it's a negative. So we get negative 32 on the right. On the left, when we multiply all the 2's together, we get 32, but that negative has to drop down. It's actually a negative 32. So in the end, we get negative 64. Same thing, we're going to use the order of operations here. They've told us what x and y represent, so we can just substitute that in like I am doing right now. And then I like to simplify the top first. So in the top, you still have to use the order of operations as you simplify just the top. You have to do the parentheses first. So it's actually 4 times 12. I'm going to simplify the bottom as we go, also one step at a time. On the bottom, we just get 16. So we really get 48 divided by 16. And guess what? If you multiply 16 times 3, you get 48. Simplify the following expression. So we're going to distribute here. We get 10x minus 30. And over in the other one, we're going to get 10 minus 6x. So now we can, that's distribution. Now we can combine like terms. These are like terms. I have 10x and negative 6x. If it helps to add the opposite, so you know that that minus sign that was red actually refers to the 6 and makes it a negative, do that. Either way, 10x minus 6x or 10x plus negative 6x is 4x. Then we get negative 30 plus 10, that's negative 20. All right, let's keep distributing on number 21. We get 6x squared minus 6x. This part gets a little tricky, folks. See this minus sign? That makes the 3 negative. Again, if you have to add the opposite or chop slash, or keep switch flip, do it. So we are distributing a negative 3 into the parentheses. If you don't distribute a negative 3, it'll come out wrong. So we get a negative 6x and a positive 3x squared, because a negative 3 times a negative x squared is a positive 3x squared. Now we can combine like terms. I've got 9x squared and negative 12x. Where you can only combine things that have the same variable with the same exponent. And when you do that, you add the coefficients, or the numbers out in front, together. But be careful, sometimes they're negative. Negative 6 plus negative 6 is negative 12. Last but not least, a snail can travel at 3 miles per hour. Convert this speed into feet per hour. To do that, you have to realize that what we're changing is really miles to feet. So you have to look up the conversion factor. It takes 5,280 feet to equal a mile. So let's write down what we have. We've got 0.03 miles. Now per hour. Per actually means division, which is a fraction bar. So 0.03 miles per hour. You can put a 1 in front of the hour if you want. It's up to you. So now here's the key. When you're trying to do this unit analysis or converting, you are going to use the conversion factor. You're going to use this, and you're going to turn this into a fraction. So you're either going to do, when you do that as a fraction, you're going to either rewrite it as 1 mile over 5,280 feet, or you're going to write it as 5,280 feet over 1 mile. That's how you turn a conversion factor into a fraction. But there is a right fraction to use here and a wrong fraction to use. So one that I wrote down we're going to use and one we should not use. The key is we want to know feet per hour. So we don't want miles in our answer at all. So we need to cancel out the miles unit. And remember, if we were solving an equation, when you divide here by 5 on the left side, when you ever take something and you divide it by itself, they cancel out. We're going to do the same thing with miles. We have a miles on top, so we want a miles on the bottom, because that way they will cancel out, right? So which fraction do I have to use? This fraction, because that fraction has miles on the bottom, so my miles units will cancel out. Oops, and 5,280 feet. So when you multiply this together, you multiply across to multiply fractions, right? So you get 0.03 times that large number. You get like 190 something, and the units on that is feet. Down below, when you multiply it together, you could have put a 1 here. Either way, you have 1 times 1, or just 1 for a number, and your unit is hour. something, which